Hi, my name is Leah Richardson, and my protein was type 1 collagen, and my mutation was a dominant negative substitution of glycine, G, for a larger amino acid in several locations. And that mutation is named as osteogenesis imperfecta. So this function basically, it typically makes up 90%, this type makes up 90% of your body's collagen. Type 1 is a very densely packed protein, and it's used to provide structure to your skin, bones, tendons, and ligaments. And it is primarily a structural protein. Um, it just basically gives the skin, bones, tendons, blood vessels, and ligaments strength and support. And the primary function of a structural protein like type 1 collagen is to provide more of like a framework for tissues and organs, which contribute to their mechanical strength and resilience and how they can bounce back from certain things like injury and tarnishing and things like that. Collagen molecules form like a triple helical structure, which is kind of like a braid, but in a wavelength kind of way, if you will, which is very strong and flexible, which allows the tissue to develop strength as well. And the stability of the body and the efficient functioning of the organs are dependent upon this structure itself and its integrity. So, typically, type 1 collagen is a key component of the extracellular matrix and is predominantly found in various connective tissue. So, in the subcellular location part of it, it is synthesized within the cell, and upon its processing, it gets released into the environment beyond the cells. It typically synthesizes in the form of a procollagen, which are enzymatically cleaved to form mature collagen fibrils. So the type of cells that typically contain this protein are fibroblasts, osteoblasts, and osteoblasts are bone-forming cells, which also produce type 1 collagen, and they contribute to the bones just as it does regularly, and so is fibroblasts, which are the primary cells that are responsible for the synthesizing of collagen in the connective tissue. So, types of organisms that this protein can be found in: animals, particularly vertebrates, and they're very crucial for protein in mammals, including humans like ourselves. So, with certain proteins comes mutations, and the mutation I had, like I stated previously, was osteogenesis imperfecta. And when the mutation comes about, the protein becomes less active. They can disrupt the normal structure and function of the protein when it is not tampered with or when it is not a mutation, basically, when it's in its regular state. And type 1 collagen is the mutation is more likely to result in a misfolded or more unstable structure rather than your typical wavelength kind of looking, if you spread it out, protein. So the functional groups that are part of the original amino acid side chain for type 1 collagens is a hydrogen atom, because glycine is the simplest amino acid and it lacks a side chain. Properties of the amino acid side chain: glycine is neutral and it would be considered hydrophobic. The charge is neutral, and glycine has a small side chain, which makes it the smallest amino acid among the standard 20. And since glycine has a small side chain and is neutral, it can't participate in hydrophobic interactions. So when the mutation ends up coming about, or if the mutation is formulated within the regular type 1 collagen protein, it can interfere and kind of weaken the strength and the sturdiness of the protein itself and its standard stability in the fibrils in the collagen. And since the collagen would be mutated, it couldn't effectively interfere into the connective tissues, which also compromises the strength of the organs and tissues in your body as well. And with this mutation, cellular and organismal like functions, the blood vessels, tissue, skin, blood, bones can definitely become impaired due to the mutation as well. And along with this dominant negative nature comes the mutated allele, or a wild type of allele that would tamper with the protein. The limitations to my project would be the lack of 3D tools, less detailed materials, meaning like whatever was being used for the project couldn't show it in depth as accurate as it could be, and also the limited labeling on the model gives less knowledge. It doesn't really tell the whole thing in its entirety, but more so just shows you the important things or what sparks a certain mutation or what is a part of the certain mutation. Also, short brief disclaimer, I irresponsibly did not have enough time to pick up or gather 3D model tools or anything else, so I try my best to at least interpret it the best I can 2D, although that was the disregarding the whole point of the project. Here you have the you have the regular untampered with normal type 1 collagen mutation. It just goes and it weaves. I tried to do it as best as I can. And here is the, classic osteogenesis imperfecta mutation. Here's where it starts. And this is where things like Ehlers-Danlos syndrome can stem from. And this is the high bone mass osteogenesis imperfecta. This is where it, clusters in at. These are the N propeptide, and this is the C propeptide. And this is just the propeptide's cleavage site here and here. And from here to about here is the classic osteogenesis imperfecta. So yes, and I was inspired to do this drawing by thelancet.com. And that is my project for type 1 collagen protein, the mutation being osteogenesis imperfecta. Thank you.